okay, this experiment is to find out how different types of bulb, okay, different type of bulbs, I take note of this part, affect the amount of light produced. And then there's a data logger here. The light sensor is here. Okay, notice this is not a fair experiment because the light sensor is at different distances from the three bulbs. Okay. So this amount of light being measured 800, 1000, 1000. Okay, fill in the boxes to show the energy conversion in bulbs. Okay, originally the question looked in this way. So it's all empty. So energy conversion in the bulb. So you start with electrical energy, change to heat energy plus light energy. So you get 1 mark for this. Okay. Then you say Anisha's teacher said the experiment was unfair. Okay, why is it unfair? As I told you just now, like hinted you, right? Because all the bulbs are not in the same distance, are not at the same distance from the sensor, and this will affect the amount of light received by the sensor. Okay, actually you can measure from here. You take a ruler, right? You can see this distance, right, is longer than the bulb B directly below. So it's not a fair experiment. Okay, this part. So you mentioned this. And then Anisha wants to use a light bulb so the room will be very bright. Which bulb should he use? So he must use the one that is furthest away and register the highest, right? So actually, he should use C. Can you see? C is furthest away and also register 1000. Okay, bulb C. Bulb C is further away from the light sensor than bulb B to the sensor. Yet the sensor can sense the same amount of light. Yeah. So you compare B with C because both register 1000, but C is further away. So that's the reason for this question. So same thing, I screenshot, I send over this one. Okay. Okay, next question. This question, this is a very interesting question. Okay, I give you some time to complete your answer previously. Okay, Muthu want to find out if different ways of placing the glasses, this one, affect how fast they dry. He used two glasses, P and Q. P is on the left, Q on the right, with the same amount of water in them. Glass P was placed upright on the table, but glass Q was being hung upside down. It was observed that the water droplet in diagram 2 was spread out more. Diagram 2 is on the right-hand side. Okay, name the process that caused so very easy, this evaporation. Okay, so just one word will give you 1 mark. So they name the process or state the process. Okay, glass Q took a shorter time to dry completely. Give 2 reasons. Okay, those 2 reasons you must state carefully. Number 1, because it's upside down, right? So the gravitational force of the earth, right, will pull the water droplet downwards. Okay, so you must mention this part. Okay, this part. The gravitational force act on the water in glass Q, causing it to drip downwards, or the water drip down due to gravity. Second reason, because they are spread out more, right? Okay, so you say the exposed surface area of water is greater in glass Q than in glass P. Because this one, they accumulate. Can you see this part? If I enlarge it, you can see, right? This part, the water droplets, they accumulate together. However, this part, they spread out. Can you see? They spread out more because due to gravity. So normally students, they cannot answer part 2 because they didn't observe carefully. So that's why in the diagram is you have to observe carefully. Then you can get the answer for part. The second reason, exposed surface area of the water droplets. Maybe you put water droplets better. Of the water droplets. Okay. Okay, put the word water droplets. exposed surface area of the water droplets, okay, in glass Q is greater. So we add in this part. The water droplets, add in here, is greater in glass Q than in glass P. Okay, this part. Let me save something first. Full solution. Wait, document. Download desktop. Full solution. Okay, let's continue. Okay, next, Motu found that when he tilt glass Q to one side and release it, it swung back from A to B. So he put at A, right? You look at this part, right? It's being hung loosely, right? So it swing to B. Okay, using energy conversion, explain why the glass swung from A to B and back. Okay, this action. Okay, so you must mention that when the glass is tilted at A, right, it possesses gravitational potential energy, which is converted to kinetic energy, causing it to swing back to B and back to A. So the concept is GPE convert to KE. Okay. So this one quite straightforward. You can answer this part, right? And then I send the answer to the chat group. Okay. Final questions. Good. I've got some time for Q&A. Okay, this final question is, you will see the empty one, right? It looks something like this way. The ball was released from point A, this part. Okay, then it rolled down, right? It was allowed to roll down the track. Name two forces acting on a ball as it rolled down the track. So because it's in contact with the surface, right? So we have frictional force and gravitational force. So you write this one. Frictional force and gravitational force, these two. More direct one. Next, describe the energy change. Describe the change in energy as the ball rolled from point A to point B. So on here, they have GPE, right? So you mentioned at point A, the ball has only gravitational potential energy. As the ball rolled down, GPE is being converted into kinetic energy. Okay, simple. Okay, part C. Why was the ball traveling at the highest speed at point B? Okay, because at B, right, is 0 GPE. So all the GPE is converted into KE. So you mentioned all the potential energy has been converted into kinetic energy. So that's why it's maximum speed. Okay, next one. The ball rolled past point B and stopped at C. That means stop at this point. This is the highest point, right? Before roll down towards B. Why was the ball unable to roll past point C? Okay, that means it cannot. Why it can't go beyond that? So you mentioned that some of the kinetic energy of the ball was converted to heat energy and sound energy, thus less energy or less KE, less energy than before to roll to higher. Okay, maybe you can be less kinetic energy. You put in the word. Less kinetic energy than before to roll to higher position. So you add in this word. Less KE than before to roll to higher position. Okay, so I send this one to you all. Good. Okay, just scenario sharing. Okay, never mind. So basically, I've gone through today's paper. Now I'll send the full solution there to all of you. Publicity. Today is 15 July, 606 now. Okay, I just sent over the full solution. Okay, please, you can download and revise it later for these questions. So basically, I have ended today's class. You can see, I do a quick summary over here. So today we have gone through this question 1 about conversion of energy. You choosing the right setup to investigate if potential energy affect, okay, if the potential energy is affected by the height object, definitely it does. Question 2 about this conversion of energy, and then suggestion to improve that. And then this traditional toy, the penguin toy, conversion of energy, and then this sliding down this part. Okay, later remind me to show you one YouTube channel about downhill skiing. Platform diving. This is the non-elastic potential energy. We saw one potential energy, one elastic potential in the SEA Games, remember? And then this one, the roller coaster, conversion of energy. And this one, the same conversion of energy and application of heat topic. Also experiment here. Kiloliter, we talk about kiloliter. Small object thrown at great height can convert to a lot of KE that can cause injury. And this one, the electromagnetic. And also why the experiment was not fair, because the light sensor is at different distance from the light bulbs. And this is a very good question, number 9, take note. Okay, this one. And question 9 as well, this. And finally, question 10. So I finished today's discussion on energy conversion. So I hope that you can benefit from my training today. So I will pause the recording.